Now that we're drawing to the end of the Unit 3 project, I kind of want to go through it, give you a little summary and overview, and talk about how you're going to close this up. Because you have to be working on the end, right? So you're kind of looking at that end point. So we started off by being presented with what the task is, and there's two parts. You want the maximum payload and as far as possible. So two issues here, the mass and the distance. So first parts, we don't start right away by like maximizing those, but that's your end. So you want to keep that in mind as you're doing this setup. The first thing you always do when you're doing a project is you do a prototype, right? You do your very first model, given the basic materials, just to get a sense of how it works, what the issues are going to be. And you can't do that well without putting your hands on the materials and trying it out. So that was the first thing we did in part A after we read through all of these rules and requirements. So you want to make sure you are following the rules and requirements, but then your first job is to really build the base model and collect some baseline data. So you want to measure, how far does it go? How are you going to set this up? And what are you going to attach it to? Where are you going to put it together? Those types of things. And then, how far does it go? Just like without any refinements. Once you've done that, you'll have a much better idea of where to go. The next part is about really the developing level. So the first part, doing just a basic model, is part of just like beginning. I made something that worked. Then the next part is really thinking it through and tearing that apart to see how you can make it better. And documenting that. So the first part is using the idea web. So you filled out the idea web, you take a picture of it, you throw it onto your Google Doc, right? And in this, you're really going through, you go back up to all these rules and requirements, and you're going to make sure you put in all the requirements and constraints. The requirements are the things that must be present. The constraints are what limits you. And then what relevant physics, so you want to try to take the things that we've been doing in class and put them in there, like what can you apply here? And then there's probably a bunch of questions you have. So especially as you go, like what things you want to, how you can do stuff. So you want to look for answers for that. So you want to first put questions, kind of generate some of those things. Then we did the problem solving setup together, and this is where we're taking what we're doing in class and we're trying to apply it to what we're doing in projects, in labs. So we did our labeled sketch with motion diagrams and free body diagrams, and I listed again the goals, like to maximize delta D and to maximize the weight being carried. Once you've kind of done that, you can maybe, this is where the brainstorming comes in. What can you manipulate in your forces or in your acceleration part or in your deceleration part to achieve those goals? So you want to be kind of specific about that. And brainstorming, excuse me, is really throwing out as many ideas as you can generate without editing. So it doesn't mean only the three things you are going to test, but like just blah, right? Just, it would be great if you set a timer for 3 minutes and you tried to generate as many ideas as you could. After you generate those ideas, then you want to pick the three that you like the best. And you can change your mind, of course, but don't stop at three, because a lot of times your best ideas happen later. And you can revisit this as many times as you want. Some people like to just throw it on a big chart or like a big piece of paper. Maybe it's a little messier. Maybe there's drawings as well. And one of the things you want to start to do is talk about the pros and cons. So in your conversation, you might then document, like what would you, or, you can actually just write it out, like what types of string could you test? And what do you think the difference is going to be between one type and another? Right? And which force do you think this is going to affect? So like the type of string, you might be like, well, smoother strings or thinner strings might have less friction, which will allow it to cover more distance. Like thinking those things through is actually a higher level skill where you're applying the physics. So those are the things you want to be generating and brainstorming. And then you want to go and do some research. So if you want to Google, balloon vehicle or something, go right ahead. See what other people have done. What variables have they added, and add it to your brainstorming, but just make sure you cite your sources. So if you found a site that, where they added, the person added like stabilizing wings so that it didn't spin. So you would write next to here, maybe you'd put like, reference 1, and you'd put that web address so that you know where you got that idea from. Okay. Some people, everyone wants to document all your ideas with pictures, writing, or video. So you could put pictures of your work, of course. Anything that you test, you want to document. And always, right, you should be submitting your doc, as you well know. Okay. The other thing you're going to do in this section is what data you collected, right? So you have to figure out how you're going to organize your data table to present the distances it traveled and the weight that it's carrying. Okay, so that stuff is important, and that's the end of task B. Doing all of that is the developing level. You have to include it all. If you've done task A and task B and you've documented it well, you're good for developing. So then what? So to get to proficient, now you've got to test 3 different variables and produce good evidence for your conclusions. Okay, so here's where highlighting evidence and reasoning becomes the difference between developing and proficient. So you have 3 variables, right, that you tested, and you tested each one like maybe 3 different data points, and you tested it at least 3 different trials, and you took an average so you could evaluate your distance, right? Once you've done all 3 of those, right, over the last 3 weeks, now you want to put the best of each of those together, right? The best model, the best aspects of each one. So whichever variable came out best for this one, whichever data point came out best for variable 2, and whichever was best for variable 3, and put it together to make your absolute best model. Then you're going to test it for mass. So this is your final model. You've got this great, what you think is your ideal balloon car, and now you're going to see how much mass can it carry and still travel a maximum distance. You're going to try to maximize both of those variables. So for that, you need some masses, a big range. You want to test small mass, medium mass, heavy masses, kind of get a bigger range until you find the upper limit of your what you think, and you're going to come to a conclusion. Okay, I think that the best model is this, and here's why. And you're going to provide evidence for that. Your presentation, you just need to finalize your document. So if you look at the rubric, engaging with content, the requirement is during brainstorming, you generate a wide variety of ideas, weighing their pros and cons before choosing one. This was in task B. So this is proficient, right? Being able to do that. You overtly apply the big ideas from this unit to the working of the vehicle and are the effects of various changes. Again, these are the proficient level requirements. Then you also want to persuade me that you used and understand the engineering design process. So this is what we've been talking about. Full completion of task A should get you to beginning. Full completion of task B should get you to developing. Proficient adds the following. You make sure you meet every single piece of criteria, and you provide evidence for that. You clearly document the construction of your prototype. You highlight evidence, which means you put it into a data table, and you give a summary statement of some sort, and you include video documentation or whatever that highlights that. You also highlight the reasoning behind your decision making, and you've done at least 3 iterations. So some people might have had time to do more, but your task C, D, and E would be the 3 iterations minimum that you'd need to do. Then there's just a couple of other things here. Please make sure you're using all your own words and images. If you're going to borrow images from other sources, you have to cite your resources, okay? I ask you to please be concise and direct and be professional. So eliminate all things that aren't important. Don't run on and on and on. Get to the point. More is not better. You can do this in a very concise way, and I will be very happy. If you want to add videos, this is a really important piece. If you're going to do video, which everyone's going to need to do, I need you to do this. You need to take all your videos and put them on one playlist. If you don't know how to do that, please ask. I'm happy to show you how. And then you can put the link to the playlist and make sure the videos are in order, and I can just run through them all. Because if I have to click on dozens of links to go to different videos, I'm not going to do it. Okay, I just don't have the time. So please do that. That's an important thing for you to do, just for to make it easier for me to see everything that you've done. Or alternatively, you could make a video, like a movie, where you compile all your pieces of your videos into a movie and narrate it, which is fine also. So if you can either have one video or you can have a playlist. And last, of course, have a clear flow of information. You can decide. There's multiple right ways to do it. It can be sequential in terms of time. It can also be types of information. Use your whatever works well for you, but it needs to be clear when I go through it. I hope this helps you make some decisions about what you need to do to finish up this project. Please watch the timing. The due date is strict on this one, so I ask that you keep track. If you are having difficulties, reach out and I am happy to help you.